All right, welcome back. In this video, we're going to go over a couple things. First off, solving systems. First, a system is when we have two or more equations in two variables to solve simultaneously. So we're going to be looking at linear systems. And to do this, we're going to be using graphing, although there's other methods like substitution or elimination or matrices. But we're going to stick with graphing for this course. So in order to do that, we're going to solve each equation for y. We're going to graph the equation, and we're going to find out where these two lines intersect. Now, two lines, so most of the time, two lines are going to intersect, as we have in this case with the red and the blue line, and the point that they cross is going to be our solution, which we have right here. And when we label that, we're going to give the coordinates of it, so we're going to get the x value, which is 2 here, and the y value is going to be 5. So the solution here would be 2, 5. It has one solution, which is the point 2,5. Now, if two lines don't cross at all, that means that they must be parallel. And in order for them to be parallel, that means that the first slope and the second slope have to be the same. And they're going to have different y-intercepts. And in that case, we're going to write no solution. And the third case, what can happen is the two lines, which might not seem like they're the same line because they're not written the same, are actually going to be the same line, and the slopes are going to be the same. So the slope of the first line is equal to the slope of the second line, and it's got exactly the same y-intercept as well. So those are the three cases. We can have one solution, which is going to be a point with an x and a y coordinate, or we have no solutions because the lines are parallel, or we have infinite solutions because they're actually the same line. So here are a couple examples. And so we're going to do this by hand, and then I'll also show you how Desmos can be a valuable tool in order to graph these and solve them. So let me color code this. So we're going to do our first one here in blue. And notice that we got this in slope-intercept form, so y equals mx plus b. So just like last time, we're going to find the y-intercept. Here the y-intercept is going to be -1, and it's got a slope. The slope here would be 1. It's got like a visible 1 out there. And so when we have a slope of 1, we can write that as a fraction, 1 over 1. That tells us to go up 1 over 1. And if we're doing this by hand, we're just going to continue that pattern, fill in all the dots that we can, fill in the dots going this way, going down 1 to left 1, until we go all the way across. And now we're going to connect those with a line. And then we're going to do the same thing for the other equation. So we'll color code this one red. And the red equation has a y-intercept up at 4. And the slope here is -3/2. So let's put the -3 on the top and the 2 on the bottom. That's going to tell us to go down 3 over 2. And bam, we've got our intersection point right there. And we can continue down 3 over 2. And there's what the red line would look like. And we've got our point of intersection. Red and blue make purple. Where do they cross? Right here at this point. That's going to be on both equations, in both graphs. And that is the point 2, 1. So here our answer would be 2, 1. Or we could write that as x equals 2, y equals 1. For the second example, again, we're going to color code this. So we got the first equation here in blue. That's got a y-intercept at -1. It's got a slope of 3/2. So we're going to go up 3 over 2. There's another point up 3 over 2. We could also go down 3 to the left 2. And then once we've got a few points, we can sketch in our line. And then we go to the second equation. The second equation has a y-intercept at -2, and it's got a slope of 3/2. So if we go up 3 over 2, there's a point up 3 over 2, there's another point, and down 3 to the left 2, there's another point. These equations have the same slope, but they have different y-intercepts. That means that they will never cross each other. So in this case, our final answer is going to be no solution, which I usually just abbreviate like this. So no solution for the second one, because again, the lines are parallel. They have the same slope. Okay, let's try at least one more here. So we've got this guy, y equals 1/2 x plus 1. Then what's the y-intercept? Well, the y-intercept is a constant, so that's going to be 1 here. And it's got a slope of 1/2, so we go up 1 over 2. Continue with the pattern up 1 over 2. And we can write 1/2 as -1 over -2, so down 1 to left 2. Put in a few dots there. We got our points. We can put in the sketch in the line. And now we go to the second equation. Y equals -3/4 x minus 4. What's the y-intercept? Well, it's going to be -4. And this has a slope of -3/4. And if we go down 3 to the right 4, well, we're going to be off our grid. So it's not likely that they're going to cross down there. We can see that they're getting further apart. So let's move it, the negative, to the bottom. That's going to tell us to go up 3 and to the right 4. So there is where they're going to cross. So the point where they cross is going to be the point -4, -1. So that's the solution for number 3. Now you're going to have some equations that are written in standard form, but you're going to do this the same way. We're going to still graph these, and let's take this first equation, 2x plus 3y. 2x plus 3y equals -3. And we want to get this into slope-intercept form. So we want to move the x's to the other side. That gives us 3y is equal to -2x minus 3. And then divide by the coefficient, divide everything by 3. So that's going to give us y equals -2/3 x minus 1. Now we've got it in slope-intercept form. So it's got a y-intercept at -1, and it's got a slope of -2/3. So we go down 2 to the right 3, plot a point. We could also go up 2 to the left 3, plot a point. There is what our equation and our graph would look like. And then we go to the second equation. Let's color that in red. Now this one just has y equals -3. So what is that going to look like? Well, remember, if it just has a y in it, it's going to be a horizontal line. So remember what I said about hoi vux. Horizontal lines have 0 slope, and they're going to be y equals. And we got vux. Vertical lines have undefined slope, and they're going to be written with x equals a number. So for this horizontal line, where is y equal to -3? Well, y is equal to -3 down here, down here. All of these points have a y coordinate at -3. We're going to have a horizontal line, has 0 slope, it's down here. That's what the line's going to look like. And where do the two lines cross? They're going to cross at this point, which is going to be 3, -3. And you can see that that's going to be a solution to either equation. So you can solve systems by graphing, and you can do that by hand, or we can do that with Desmos. So let me pull up Desmos here. All right, so here we are in Desmos, and to solve a system in Desmos, all we're going to do is type in the first equation. Let's take y equals the 1/2 x, remove over here, plus 1. So it's coloring this already in green. If you want to, you could change the color. You just go up here to the gear icon, and then click on here. You can make that a blue line or whatever color you want to. And click done. And then if we click here, we can add another line. And we can type in our second equation, y equals -3/4. Move over here, put the x minus 4. Again, if we wanted to change the color, we can do that in the settings. And we'll make that a red line. You could even make it a dotted or dash line if you wanted to. And it's showing us both equations. And if we click on it, it will even show us where they cross. So Desmos will automatically find the intersection point. And if you click on it, it will label it for you. So we have a solution of -4, -1. We can hit the x's here to clear those out. And let's try our last example, which was 2x plus 3y equals -3. And it had this y equals -3. We said that that was a horizontal line. Again, we can see both lines here. Here it's got it graphed in black and red, and they cross at 3, -3, as we saw when we did by hand. Okay, do one more example of a system. Let's look at number 3 here. So this one, we've got 2 equations. Both of them are in standard form, so we need to solve these. Again, if you can, I like to color code these. So our first equation here is 3x plus y is equal to -2. And we want to get the y by itself, so we move the x's to the other side. This gives us y equals -3x minus 2. And when we're graphing lines, we're going to use the y-intercept first, which is -2. And then our slope here is -3. And we think of that as -3 over 1. So that gives us direction to another point, -3 down 3 over 1. There's another point. Or we can go up 3 to the left 1, up 3 to the left 1. When we are solving a system, it's good to have in as many points as possible. We're going to connect those with a straight line. And now we can go to our second equation, which is x plus 2y is equal to 6. Subtract off x, move it to the other side. That gives us 2y is equal to -x plus 6. We're going to divide everything by 2. -x is the same as -1x, so that's going to give us y is equal to -1/2 x plus 3. 6 divided by 2 is 3. And so that gives us our second equation in slope-intercept form. The intercept is 3. The slope is -1/2. So it's going to go down 1 over 2. Now we can see it's not going to cross that way. But if we go up 1 to the left 2, there it crosses. And we've got our second line. That's what the graph is going to look like for the system. The solution is going to be where these 2 points intersect. So that's going to be -2, 4. All right, in the next part of this video, we're going to go over some descriptive stats, how to look at graphs and interpret them. So descriptive stats, we're dealing with statistics and data and how to represent and analyze it. So there's different types of graphs that you're going to have. So here's an example of a pictograph, which is going to have pictures. Maybe this is showing your favorite fruit, for a class or something. So the stars here might represent 5 people. So each star represents 5 people. And, it's easy to make comparisons here. You can tell, okay, what fruit is the favorite in this class? Well, it would be bananas. We can quickly tell, what's the ratio of apples to oranges? It would be 5 to 4. Even though, if we look at the apples, the number of people that like apples is 25. The number of people that like oranges would be 20. But we can just use the pictures in order to make these comparisons and to do the ratios and the percentages. A circle graph or a pie chart allows us to look at parts of a whole. So it's good if we're trying to represent a budget or, how our resources are spent and how our time is allotted. A scatter plot is good when we're showing some kind of change, especially over time. So usually the x-axis here might represent time. And then we have a bar graph. This is going to usually be for categorical data. So we might not have numbers here on the bottom. We might have different types, colors or different types of fruit, for example. And it's going to tell us how many people are in each category. A line graph is similar to a scatter plot where we actually connect the points. And again, a line graph is going to show us how something changes over time, like maybe the price of a certain stock or the price of gas. It goes up, it goes down, and we can see those changes over time. And it helps us to look at the rate of change or the slope over a particular period. A histogram is similar to a bar graph or a bar chart, except a bar chart is usually for categorical data like colors or names or car brands, whereas a histogram is going to be for quantitative data, and this might be test scores or IQ or ages, and it shows us how many people are in each quantitative bin here. So from 0 to 10, it looks like we got 1 person there. From 10 to 20, we've got 3 people or 3 things in there. And then 20 to 30, it's 6 people, and so on. So I want to go over the questions from the sample quiz. So this is what my sample quiz looks like. And when you do the actual quiz, it's going to have the same type of graphs, but slightly different questions. So just make sure you're reading the questions carefully And also, I might change some of the numbers here. So instead of 300 people, it might say 400 people. So let's go through the sample quiz. So for number 11, we're using the graph here on the left here, this pictograph. Notice that each picture of a fish stands for 6 fish that are actually caught. It says, who caught the most fish? How many? Well, we can see that Jennifer has the most pictures next to her name, so she caught the most. How many fish did she catch? 1, 2, 3, 4, 5, 6, 7. Did Jennifer catch 7 fish? Not quite, because remember, each picture stands for 6. So she actually caught 42 fish. So the correct answer would be Jennifer catching 42. Number 12 says, what is the ratio of the number of fish Emily caught to the number of fish Joseph caught? So we're going to be comparing Emily to Joseph. This is going to be a ratio. We can write it as a fraction, or we can use the colon here. And first off, Emily, 1, 2, 3, 4, 5, 6. There's 6 pictures there, which is actually 36 fish. And Joseph has 2 fish. Now we're going to get the same ratio whether we do the pictures or we do the actual. So this is going to be 6 to 2. And we're going to make sure we reduce it as well. But if we use the actual number, it would be, 6. Let's see, that would be 36 to, and Joseph had 12. 36 to 12, we can divide those both by 6. We would get the same thing, 6 to 2. But for our final answer, we don't want 6 to 2, we want 3 to 1. So make sure you're reducing your ratios down to the lowest ratio. What percentage of fish did Michael catch? So again, we can just use the pictures. We don't have to use the actual count. So if we look at Michael, Michael has 1, 2, 3 pictures. Our percent is going to be the part out of the whole. So he caught 3. How many do we have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, and what is this? This is a half, so 20.5. And we want to make sure we reduce that. 3 over 20.5 comes down to 0.1463. And we're going to write that as a percent. It says to the nearest percent. So it's going to round to 15%. We will move the decimal and round it. Okay, for question 14, it says, how many adult staff were at the day camp? And it tells us that there were 300 people. Now, again, when you take the actual quiz, I'm going to change that number. So it's not going to be 300, so it's going to make these questions a little bit different. How many adult staff were at the camp? Well, if we look here, it's 17% of the total. So we've got 17% of 300. That means we're going to take 0.17 and multiply by 300. And what does that give us? That's going to give us 51 adult staff. What is the ratio of adult staff to brownies? So this gives us parts out of the whole, but we're only concerned with the ratio. So when you do in ratios, you could use the percents here. You don't have to find the actual number. So the adult staff is 17%. The brownies is 34%. 17 over 34 reduces to 1/2. So we get 1 over 2. Number 16 is the trickiest problem because this one we're adding 60 new brownies join the program. What is the new percentage of brownies in the day camp? So, well, first off, we need to know the number of brownies we have now. If we take 34% of what we have now, 300, 0.34 times 300 is going to give us 102 brownies. Now we want to find the new percentage. So again, how do you find percentage? It's part over whole. So taking the part over the whole. If we add 60 new brownies, there were 102, now there's going to be 162. But we have to do that out of the whole. You might say, well, it's out of 300, but 60 new people joined. So it's not 300 anymore. The new whole amount is going to be 360. So this is the tricky part, is making sure you're adding 60 to both the top number and the bottom number. Those 60 people, they're going to add to the numerator and add that to the denominator to get the new percentage. So 162 divided by 360 gives us 45%. Here we've got a histogram. Question 17 says, how many students have a final score of A? So make sure you're looking at this chart up here. This tells you, okay, all the A's are between 90 and 100. So this is the A's. How many do we have here? Well, it's between the two lines. If we go here, this line's at 4, this line's at 6. So if I'm between them, that's got to be 5 people. How many students, and maybe we'll just make a note of that up here, so that's 5. How many students had a final score greater than 80? Well, that's going to be 80 to 90 and 90 to 100. So it's going to be both of these bars. So the 80 to 90, that's above 12, so that's going to be at 13. And we already have the 5 here, so that's a total of 18 had a score higher than 80. For the last two parts here, we're going to have to find out the rest of these numbers, so let's just write them down. So what is this going to be at? This is at 9, this is at 6, this is at 2, this is at 1, this is at 2, and this is at 1. So you got to make sure you're reading these. And here it's passing to failing. So this says below 60 is failing. So since they're failing, let's make that red. Anything in this part here is failing. And how many do we have there? We have 1 plus 2 plus 1 plus 2. So we've got 6 students failing. And anything from a 60 on up is passing. So that's 15 plus 5 is 20 plus 13 is going to be 33. So if we do a ratio of passing to failing, that's going to be 33 to 6. But we want to reduce that. We can divide those both by 3. So that's going to give us 11 to 2. What percentage of students scored a C or greater? So where does the C begin? 70 to 80 is the C range, or greater. So it's going to be all 3 of these. So that's going to be 9 plus 3, that's 22, plus 5, that's going to be 27. Over the whole, how many do we have total? Well, we can just add these two numbers together because this was the passing students, this was the failing students. So total, we had 39 students. And if we make that into a fraction, 27 divided by 39 comes out to a decimal of 0.6923, which is 69%. All right, in this last part, we're going to look at some statistical measures. So we've got 3 different ways of kind of telling what the center of our data is going to be. So like if I say, okay, what's the typical income, in the United States? If I look at mean income, well, the mean income might be like $1 million, but that's not the typical. That's not really a good way because, when we're looking at income, sometimes it's skewed. So, in the United States, the income might look like this. It's got this long tail out here, and then over here you might have some billionaires or whatever who make billions of dollars, and then most people, though, are in this chunk, and then you might have a fewer people over here. So if you look at the mean, that might throw off the typical value. So a lot of times they'll look at the median, like the center value, the middle number instead. So there are 3 ways of telling what the center, the typical number is. The first one is the average. To get the average, we're just going to add up all the data values and divide by how many we have. If we're looking at the median, then we're looking at the middle number. And that's a good estimate, good way of measuring the center when the data is skewed. And the mode is going to give us the most frequent number. So there may be one mode, no mode, or more than one mode. And for the median, It's going to be the middle number, but if there is no exact middle, then we're going to take the average of the two middle numbers. We're also going to look at how to construct what's called a box and whisker plot. So, a box and whisker plot is going to look something like this, all right? And it's going to have a box, and it's going to have some lines off to the side. And to do this, we're first going to find the median of the data, the middle part. Then we're going to find the middle of everything to the left of the median. Then we're going to find the median, or the middle of everything to the right of the median. And we're going to find the highest number and the lowest number. The range is going to be the difference between the highest and the lowest. And we're going to find the interquartile range, which is going to be the difference between this Q3 and this Q1. So here's an example. Now, when you're doing a box and whisker plot, it's going to be helpful to put your numbers in order. So I've already put these numbers in order, but if they're not in order, you would have to list them in order first. So I'm going from smallest to largest. And here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values. So the middle number means it's even. It's going to be 1, 2, 3, 4, 5, 6. So this is the 6th value. This is the 7th value. The median is going to fall between these two. The median is going to be the average of 35 and 36. If you add those two numbers together and you divide it by 2, 35 plus 36 divided by 2, you're going to get 35.5. Now we look at everything to the left of it. So exclude the median. So if the median is in your list, you're not going to count that. You're going to look at everything to the left of the median. And you're going to do the same thing. Well, what's the middle number here? If it's even, well, then you got to find the number that's between those two middle numbers. In this case, it's between 23 and 24. So it's going to be 23.4, or 23.5, sorry. It's going to be 23.5. And that's going to be our Q1. And we do the same thing for the numbers on the right. So look at all the numbers to the right of the median and find the middle number, or the median of those to the right. In this case, it's going to be 40.5, so that's our Q3. And we also need the lowest number, so that's going to be our min, and we need the highest number. That's going to be our max. Okay. If I asked, what is the range of this data? Well, the range is the high number minus the low number. It's the max minus the min. Maybe. So let me just write down max minus min. So it's the maximum minus the minimum. And what do we have here? We have 48 minus 21. So what is the range going to be? The range is a single number. It's just how far, how spread apart they are. So that gives us 27. The IQR, or interquartile range, is going to be Q3 minus Q1. Q3 was this 40.5. Q1 was this 23.5. And if we subtract those, we get 17. So 17 is the IQR. All right, so let's see. What do we do for our box and whisker? Well, for the box and whisker, we need these 5 numbers. We need to know what the minimum is. We need to know what Q1 is. We need to know what the median is, Q3, and the maximum. And so we make, first off, a little dot. So I'm going to make a dot at 21. I'm going to make a dot at 23.5. 23.5. I'm going to make a dot at 35.5, which is right there. I'm going to make a dot at 40.5, which is right there. And I'm going to make a dot at 48. Now, at Q1, I'm going to make a vertical line. At the median, I'm going to make a vertical line. At the Q3, I'm going to make a vertical line. That's where my box is going to go in this box and whisker plot. And then I'm going to draw out whiskers going to the max and to the min. And that's our box and whisker plot for this graph. I'm going to do another one by hand, and then I'm going to show you how to do this on Desmos. All right, in this example, slightly different numbers. Now I've got 13 numbers. So again, I already have them in order. And we're going to find the middle number. So since there's 13 numbers here, the middle number is going to be the 7th number. So we got 1, 2, 3, 4, 5, 6, 7. So now this 36 is the median. And we're going to look at all the numbers to the left, find the median there, which is 23.5. All the numbers to the right, find the median there. In this case, we're going to have to add these two up and divide it by 2. So that's going to be 44. So we've got our Q1 and our Q3. We've got our min at 18 and our max at 50. So again, we're going to draw little dots first. So make a dot at 18, make a dot at 23.5, make a dot at 36, make a dot at 44, and make a dot at 50. At Q1, median, and Q3, draw a vertical line, make a box, draw out your whiskers to the left and the right, to the min and the max. The range, if I ask you the range of these numbers, the range is going to be the max minus the min. So in this case, it would be, what would it be, 32. And the IQR is going to be 44 minus 23.5, which is going to be 20.5. All right, here we are on Desmos. And if you want to do a box plot on Desmos, all you have to do is type box plot. I've already done it here. So you would type box plot. Then you have your parentheses. And then your data set is going to go in these square brackets. So here I've already got the data set for the first one. And then make sure you end it in parentheses. So again, it's box plot, parentheses, bracket, and then your list. Your list doesn't have to be in order when you do it this way either. It'll draw it automatically. And then sometimes when you're doing this, you might not see it on your graph. If you click on this little zoom fit, it will automatically go to the box plot. So it doesn't matter where it is or where your graph was initially. If you click on this zoom fit, it will automatically go there, and then you can zoom in and you can go along these points, I think, and find out where each of these values are. So you can see, if we zoom in here, where the minimum is, where Q1 is, where the median is. So the median here is at 35, and Q3, and the max. And we can do the same for the other one. Now, if I'm doing two at a time, you might get some overlap here. You can change that if you change the offset. So if I want that to be a little bit higher, I can just put the offset here at 3, and I can show both of the box plots in a side-by-side comparison. Desmos has some other functions. So one of them is mean. So Desmos has some other functions. One of them is mean, or the average. So if I want the average for my list, again, I'm going to type in mean, I'm going to type in parentheses, and then my list is going to go in brackets, and it's going to tell me what the average value is. I could also do the median. So there's median as well. The median is 35.5. And you can even do the quartiles. So to do the quartiles, it's a little bit different. You're going to type in quartile here. And then at the end of the list, you need to have a comma. And if I type in 0, it's the 0th quartile, which is the same as the min. So you can see that 21 is the min. If I type in 1, I'm going to get the first quartile. If I type in 2, I'm going to get the median. If I type in 3, I'm going to get Q3. If I type in 4, I'm going to get the maximum. So quartile is going to be a helpful function in Desmos to help you to find those 5 numbers: the min, Q1, the median, Q3, and the maximum. All right, so in this video, we went over solving systems, and we went over some basic statistics questions and how to make a box and whisker plot and find some of the statistical values that you'll need for the quiz. Let me know if you have any questions, and we'll see you next time. Bye!